Hello and welcome to this video in which we'll be inspecting the mechanics of how a hum-cancelling noiseless stacked single coil works. A stacked single coil works much like a humbucker, so we'll start with a typical humbucker, which most people will be familiar with, as a reference, and then we'll adapt it into a stacked pickup. Here's our standard humbucker. As far as what we're interested in this video, we can remove quite a lot of the parts of the humbucker, and we're left with a very basic group of components that are relevant to our discussion in this video. We have two coils of copper wire, where the charge of the strings vibrating is generated, and we have a bar magnet underneath which charges the strings. The magnet does this by charging the screws and the slugs of the pickup. Now, if we place the strings above the pickup, as they should be, we'll see that the screws and slugs then polarise a length of string above each coil, north above one coil, and south above the other. The two coils are what we call RWRP, or reverse wound reverse polarity. Both of these things change the phase of the output by 180 degrees. When we have two, we turn it 360 degrees, or the same relative to the other coil. Therefore, the two coils are in phase. But the hum doesn't care about the polarity of the string, so that still remains out of phase, and therefore is bucked, hence the name humbucker. Now, let's adapt this humbucker to make it resemble a stacked single coil. We take our two side-by-side humbucker coils and we just simply put them one atop the other. Stacks are typically made with Alnico rods running through the centre of the coils, similarly to how a typical single coil is made. These rods act to magnetise the strings, much in the same way as a bar magnet did before. But notice that we don't have two polarities in the same way as we did before, but we still have the two reverse wound coils. The two coils sense the same length of string, a length of string the same as a standard single coil, giving us a similar tone due to picking up the same range of harmonic content. This is one of the main reasons humbuckers and single coils sound so different. But the issue with two coils sensing the same polarity of string whilst being reverse wound relative to one another is that the outputs of each are out of phase, or in simple terms, they cancel out each other. As you'll notice as you move your pickups up and down, the output of the pickup will be lower as it's moved away from the strings and vice versa. The same principle applies to the coils of a stacked pickup. The lower hum-cancelling coil is further from the strings, therefore the cancellation effect is significantly less than the output from the top coil. The background noise, or 50 or 60 Hz hum as it's sometimes known, that the dual coil structure is designed to remove, is out of phase with each other as well as the string signal. When the coils have the same magnitude of hum noise, they will silence it. In theory, but this isn't quite 100% in practice. To summarise, a stacked single coil is essentially a humbucker with both coils on top of each other, rather than side by side. They sense the same string length as a standard single coil, giving us a far more single coil-like tone due to the harmonic content read along said length. The length of the string is shared between the coils, therefore they both sense the string charge the same polarity. The coils are wound in opposite directions, making them out of phase in relation to both the hum that we wish to remove and the string signal. The top coil is our signal coil, and the bottom coil is a subtractive coil due to being out of phase with the top coil. Thank you for watching this video about the basics of how stacked pickups work. This is the first video of a series that will delve deeper into stacked single coils. Next video we'll be inspecting the issues that we pickup manufacturers face when trying to voice a stacked single coil like a traditional one, and why there's so many on the market that fall flat on their face trying to do so.